Hello everybody. So clearly I am not in today, but the math must go on. We're going to do a full lesson today. It's going to be the same lesson that first period got yesterday. So, as all of our classes do, we're going to start with a warm-up. This warm-up is a lead into what we are going to do today, but this is a Algebra 1, Algebra 2 level linear equation. So go ahead and pause this video and then do the problem, and you will type your answer in and then we will go over it. All right, so I am not sure of the approach you guys took. I'm going to take the approach of clearing the denominators. And when I taught Algebra 1, this is what I taught, because nobody likes fractions. Nobody wants to add and subtract fractions. We did it last learning target. I don't really think anybody had a good time. So now that we have an equation and all we have to do is keep it balanced, we're going to take advantage of that and we are going to clear the denominators. We are going to use the LCD to do so. Again, when it's just numbers involved, you could use any sort of common denominator and your calculator will reduce it for you and it's no big deal. But once we get into more expressions in the denominator, again, we have to focus on the LCD, the least common denominator. So we're going to do that here as well. I have two denominators, right? Because 6x is really just 6x over 1. So this factors to just 3 and 1. This factors to 3 times 4, which is really 3 times 2 times 2, and then 1, just factors to 1. So if I'm thinking about my least common denominator, we can see, okay, just like we did with expressions in Learning Target 1, they have a 3 in common, so I take that once, and then they have 2 2's not in common, so I have to put those both in my LCD as well, right? You take anything they have in common once, and then anything they don't have in common, you also have to multiply in. So my LCD ends up being 12. Now, to clear the denominators, what I can do, because this is an equation, and the only rule of an equation is that you must keep it balanced, right? Whatever you do to one side, one set of terms, you have to do to the other. We can clear the denominators by multiplying each term by the LCD. So if I take 7/3 x minus 33 over 12 equals 6x, and I multiply the whole thing by 12, I'm going to have 12 times 7 over 3x minus 33 times 12 over 12 equals 12 times 6x. Now, notice I didn't actually multiply it out, right? Again, with numbers, your calculator can do all this for you, multiply and simplify. But once we're working with expressions, like polynomials, I should say, you're not going to actually multiply them out. Because the whole point of this, the whole point of multiplying by the LCD is that things will cancel, right? 12 divided by 12 goes away. 12 divided by 3 just leaves you with 4, right? So we'll have 4 times 7x minus 33 equals 12 times 6, which is 72, 72x. Right? Now you can see that we do not have any fractions. There is not a fraction in sight. And then this is 28x minus 33 equals 72x. Start that back up here. And now this is just a linear equation, right? There's no longer any fractions involved. It's not a rational equation. It's just a linear equation. So I will do 72 minus 28. So I'll have negative 33 equals 44x. Divide both sides by 44, so negative 33 divided by 44. But then that reduces, because both the top and bottom are divisible by 11, to negative 3/4 is x. Okay, and this is the method we are going to use to solve more complicated rational equations where there's variables in the denominator, we are just going to get rid of the denominator. That's our first step so that we don't have to deal with fractions. Okay, so the learning target we are going to go over today is learning target 2 of Unit 4. I can solve rational equations algebraically. And we're basically just going to practice today. We're going to use the same steps we used in the warm-up, except for obviously they'll be a little more complicated because there's more variables involved, to solve some rational equations. So, take a moment to write down the steps because these are what we are going to go through. Right? The first step of solving a rational equation is to multiply all terms by the least common denominator. Right? We're going to clear the fractions. We're going to solve the fraction equation by getting rid of the fractions. Now, there's obviously some steps that come before that, but we've already done those, right? You guys already know how to find the LCD, right? So yes, the real first step, the pre-steps, would be to factor the denominators, just like we did in last learning target, and then find the LCD. But the first step for actually solving these rational equations is to take the LCD and multiply every term by it. We can't do this in learning target 1, adding and subtracting expressions, because those were expressions, not equations. And equations we have a little more flexibility with because we just have to keep it balanced. You know, expressions you can't change the value at all. With an equation, so long as we're treating all terms equally, we can kind of do what we want. Okay, you can also cross multiply. We won't see much of that, but you know, if you have x over y equals a over b, you can cross multiply bx equals ya. We won't see a ton of that, but that is a thing if you've heard of it. Then every time you do this, stuff will cancel. That's the whole point. Cancel what you can cancel and algebraically solve the rest. After you cancel, there should no longer be any fractions. If you cancel and you're still left with fractions, your LCD was wrong or you canceled wrong. Okay? Then you'll algebraically solve it just like we've been doing. You'll always be left with either a linear or quadratic equation to solve. This is why we have to use the least common denominator, because if you don't use the least common denominator, you could end with a cubic or a quartic that you can't solve. And then last but not least, as we've seen on basically everything we've been solving this semester, you have to check your answers in the original. We can't divide by 0, and anytime you're multiplying by a variable, you could end up, giving yourself an extraneous solution. We saw that in the radical equations. So we just need to check our answers in the original. Again, it's just plugging in, making sure it's a true statement when you plug in. So take a second, pause, write this down, and then we'll do some examples. All right, now that you've got that down, let's apply these steps with a little leveled up of a problem. Right, so clearly this is a rational equation because I've got fractions involved. So what I'm going to do first is I'm going to factor the denominators to get an LCD. Now, neither of these are quadratic, so remember factors are just what multiplied together makes up something. So the only factor of this is x. Factors of this, x and 5. Right, now 1 is a factor of everything. I'm not going to take time to write 1 every time, because it's not going to affect anything. But this one would be over 1, so it doesn't really have any factors. So when I'm thinking about my LCD, right, I'm going to take what they have in common once. I don't want to double count anything. So I just need 1x, and then whatever's left over. So in this case, that's 5. So my LCD is going to be 5x. Since I have my LCD as 5x, that means what I am going to do is multiply every single term by 5x, right? So I'll have 5x over x equals 5x times 6 over 5x. Again, I'm not multiplying anything together until after I've canceled, plus 1 times 5x. Okay, and we can see in the first one, we have x over x, so those will cancel each other out. Second one, we have 5 over 5 and x over x, right? 5 divided by 5 is 1, x divided by x is 1. That's why it cancels, because it reduces to 1, and multiplying by 1 doesn't mean anything. So then I'm left with 5 equals 6 plus 5x, and now I no longer have a rational expression. It's linear. Subtract 6 from both sides. Divide both sides by 5. Negative 1/5 equals x. The last thing I have to do is check my equation, make sure all is well, all is sound with what I found. Remember, checking means you plug into the original. So 1 over negative 1/5 equals 6 over 5 times negative 1/5 plus 1. There's a couple ways you could do this. You could just type it into your calculator. This is 1 over a fraction, so it's going to flip, right? Keep, change, flip. Then this is going to be negative 6, because 5 times negative 1/5 is just negative 1, because these will cancel each other out. Plus 1, that does work. So we are done with this problem, and we know that 1/5 is our answer. Let's keep this example train rolling. For this next one, again, any numbers or anything without a denominator just has a denominator of 1. We want to look and see if any of these denominators can be factored. They cannot be factored, right? There's nothing other than 1 times a plus 3 that's going to give us a plus 3. Now, you could get into like radicals and square roots, but we're not going to do that here. Nothing that multiplies to give you a plus 2. So when I'm looking for the LCD, they actually don't have anything in common. Because when we're saying what do they have in common, we are talking about what factors do they have in common. So sure, they both have an a, but a is not a factor here, right? It's not a times 3. Remember, factors are what multiplies together. So they actually have nothing in common. So our LCD is just going to be, we take a plus 3 once to account for it, and we take a plus 2 once. And again, I'm not going to multiply anything out here. Then what I'm going to go ahead and do is our next step, which is really the first step of actually solving, which is multiply every term by the LCD. So I'm going to multiply a minus 2 times a plus 3 and a plus 2. Again, I'm not multiplying it out. I'm just showing that it would be multiplied. A plus 3 times a plus 2, and then a plus 3 times a plus 2. And before I do any multiplying, any simplifying, I want to see what cancels. So we can see in the first one, we have a plus 3 over a plus 3, so that's going to cancel. Second one, nothing cancels. And last one, a plus 2 over a plus 2 cancels. So now I have a plus 2 times a minus 2 minus 1 times a plus 3 a plus 2 equals 3 times a plus 3. I cleared the denominators. This is no longer a rational equation. There's no longer any fractions involved. So now I just go forward and I solve it. And we know to solve this, we're isolating a, but we can't do that till we've multiplied some things out. So I'm going to take each of these and FOIL them. So a squared plus 2a minus 2a minus 4. Then minus, right, we're subtracting the whole thing, so I'm going to put brackets here. A times a is a squared, 3 times a is 3a times 2 is 2a, 3 times 2 is 6, and then 3a plus 9, right, just distribute that 3 in. Combine like terms, we can see these will cancel. Then we will have a squared minus 4. This is going to become 5a, right? Minus 4 minus a squared minus 5a minus 6, right? I'm distributing that negative in. Now I combine like terms again. A squared minus a squared cancels. I've got negative 4 minus 6, which is negative 10. Negative 10 minus 5a equals 3a plus 9. Get my a's on the same side. I'll add 5a to both sides. Get my numbers on the same side. I'll subtract 9. Then we got a weird answer coming. negative 19 equals 8a. Divide both sides by 8. We have a equals negative 19 over 8. Now that is how we solve it. Next we have to check it, and this one I am going to type into my calculator because it is the fraction, or the answer is a gross fraction. So to check it in my calculator, I'll do negative 19 over 8 minus 2 in parentheses divided by negative 19 over 8 plus 3 minus 1 equals 3 over negative 19 over 8 plus 2. And I'm just going to calculate what this is out in my calculator. Okay, on the left-hand side, I get negative 8 in my calculator, and then I'll do 3 divided by parenthesis again, because I need the negative 19 divided by 8 in its own parentheses, plus 2 close parentheses, and I get negative 8 on this side as well. So this is true, right? That is enough to show that you checked your work. I can understand what you're doing and saying, which means that our final answer here is A equals negative 19 over 8. Now this one is a little new and exciting because we actually have to do some factoring of our denominators before we can find our LCD. So V is as factored as V can be, but V squared minus 5, our next two denominators, we can pull out a GCF there, right? We can't use like the AC method. We can't be like, oh, what multiplies to V and or multiplies to 0 and adds to negative 5, right? We don't have a C value. So we're just looking for a GCF, and you can see that they both have a V in common. So these will factor to V times V minus 5. Remember, factoring out a GCF is kind of like reverse distributing, right? You're trying to pull out, if we were to multiply this back in, you would get what we started with. So then when it comes to finding my least common denominator, my LCD, I look at what they have in common. Now, one of the things they all have in common, I still only take it once. So they all have a V. So I still only, put it in my LCD once. I don't double count anything. Even though they don't all have a V minus 2, V minus 5, even though only 2 of them have a V minus 5, it still is in common with some of the denominators. So I still only take it once, and then you can see there is nothing left over at that point, right? So now I have my LCD as V times V minus 5, and the next thing I'm going to do is multiply it into all of my terms. Now notice when I've rewritten this problem to multiply the LCD in, I've left some space to do so, but also I made my denominators in factored form. I put my denominators in factored form so it's easier for me to see what cancels. Okay, so I would recommend you rewrite the problem first, then you go in and multiply each term by the LCD. So we'll have V times V minus 5 times V times V minus 5 times V times V minus 5. Again, it's only going to the numerator. We're allowed to put it only to the numerator because this is a equation. We're keeping balanced. We did the same thing to every term, so there's no foul play. Now I can see what cancels. We can see in the first one, V over V cancels. In the second one, we've got V divided by V and V minus 5 over V minus 5. And then in the last one, V over V, V minus 5 also cancels. Okay? Then we are left with, from the first term, V minus 5. From the second one, plus 3V plus 12, and from the last one we're just left with 7V minus 56. Right, you can see again we have a linear equation, and now we just solve this like we would have in Algebra 1. So I can combine like terms on this side real quick. I have V plus 3V, which is 4V. Negative 5 plus 12 is going to leave us with a positive 7. 7V minus 56. We need to get the V's on the same side, so I'll subtract 4V from both sides. We'll get the numbers on both sides, so I'll add 56. So then I will have, 56 plus 7 is going to be 63. 7V minus 4b is going to be 3v. Divide 63 by 3. We will get that v is 21. Then, last but not least, we just need to check our answer. Again, this just means you're plugging in, so we'll have 1 over 21 plus 3 times 21 plus 12 over 21 squared minus 5 times 21. Remember, it always goes into the original. Not this. It'd be easier to check in this, but that's the whole point, is that we're checking it in the original. Equals 7 times 21 minus 56 all over 21 squared minus 5 times 21. And again, I'm just going to put this in my calculator carefully, this in my calculator carefully, and see if I get the same thing on both sides. Okay, I got 13 over 48 on this side. This ends up being 91 divided by 336, which is 0.2708333, but that is also 13 over 48. Since the left-hand side of the equation equals the right-hand side, we'll check it off. Okay, I'm going to pause right here and give you guys a chance to ask questions. So I will reply to those questions within Edpuzzle or touch on them on Tuesday so that everybody can get the answer. Next, I just wanted to show you guys that this problem right here is actually worked out in the slides step by step, and you can see there's an example of a quadratic where you get 2 answers and only one of them works. Right, so you can see the steps that were followed are the same. The first thing you do is factor the denominators, and it's really important that you guys, write down these steps and try and do these things step by step, because they look super overwhelming when you just first look at the problem. But if you take it one at a time through these steps, it's more manageable. So the first thing we'll do is factor the denominator. So you factor a 5 out of 5x plus 5, and then you factor the quadratic x squared plus 3x plus 2 to x plus 1 times x plus 2. So that gives us the LCD of 5 times x plus 1 times x plus 2, right? Because we can see, okay, they have a x plus 1 in common, so that's going to go into the LCD. They have an x plus 2 in common, so that's going to go to the LCD, and then there's a 5 left over, so that goes to the LCD. Then you just take every single term, all 3 terms, and multiply the numerator by the LCD. Then you look at each of, and you have to do it to every term because this is an equation we're trying to keep balanced. So then you look at each term individually and cancel what can cancel. So we can see in the first one, there's a 5 in the numerator and denominator, that cancels. There's a x plus 1 in the numerator and denominator, that cancels. So you're left with x plus 2 and x, right? And then in the second one, x plus 2 cancels, so you're left with 5 times x plus 1. And then in the last one, we can say that x plus 1 cancels and x plus 2 cancels, so we're just left with 5. Now that's a quadratic. You get it equal to 0, you factor, you solve, and then you plug your solutions into the original equation, right? In all the ones we've done, it's always important that it goes into the original. The reason we have to check is because just like when we were solving radical equations, you have the potential of getting an extraneous solution, because multiplying by variables like we did here is technically not an undoable operation because we don't divide by variables when we're solving. So you check both. You can see we get 0 in the denominator when we plug in -2. Well, you can't divide by 0. That's undefined, so -2 does not work. But 5, we get 1/6 equal to 1/6. Now you have 2 options for showing your work. You can either write this step down, just show that you're checking it by plugging in, or you can write this step down, because if you've actually calculated that both sides equal 1/6, then I know that you must have plugged it in, right? It's just a matter of I can't read your mind. I don't need to see all those steps. It can be this top one or this one. All right, we are going to do one last problem kind of together that I'm going to walk us through, and then you guys will do a problem that you will submit to Schoology as your exit ticket, and then it will just be homework work time. So I'll talk about the homework first, then I'll assign the exit ticket so you can go do that. So the first thing we do when we are solving these is factor the denominators, right? That's always the first step. So we can see x plus 8 is already factored. Again, factoring is things that multiply together to give you something. So the only thing that's going to multiply to x plus 8 is 1 plus x plus 8. So that's good. X squared can technically be factored into x and x. Not really going to end up mattering here, but it could. So we factor that to x to the x. And then this one's a little trickier because it's like, whoa, this is a cubic. I don't know how to factor a cubic, but we do know how to take out a GCF. If I see things in common, I can factor it out. They have an x squared in common, so I pull that out. Okay, I'm like reverse distributing. X cubed divided by x squared is x, so I'm left with an x. 8x squared divided by x squared is just 8, so I'm left with x plus 8 under the denominator there, or as the denominator there. So now I can find my LCD. We know that for our LCD, we take what they have in common once. So they have an x plus 8 in common. So I'm going to take x plus 8 once. And then they also have two x's in common, right? We have a x squared and an x squared. You know, if it was only an x that we could take out, then they would only have one x in common, right? So then we add or multiply in that to our LCD. So our LCD is x plus 8 times x squared. So let me rewrite the equation. This is how I do these. I rewrite the equation, give myself lots of room to grow, and then I'm just going to multiply every single term by the LCD. And I'm just going to cheat here. But it's really that easy. I'm basically just copying and pasting the LCD to each numerator because that's what you do. That's what the step is. Okay, the reason we can do that is because we've kept this equation balanced at this point. So long as you do the same thing to every single term, to both sides, every single term, then you are, good to go. You can really, the world's your oyster. You can do what you want. But we're making an educated choice here, and we are doing it by the LCD because that's what's going to clear the denominators. Now, normally what I do, and I'm going to go ahead and do it, is I make sure that I write all of my denominators in factored form, right? I factored them at the beginning to find the LCD. I want to keep them factored so that I can, more easily cancel, right? You can only cancel factors, so it needs to be in factored form. So then I look and I see, are there any common factors in the numerator or denominator? Now remember, okay, they both have an 8. That's not a factor, it's plus 8. Factors are things multiplied together. So looking here, they both have an x plus 8, right? X plus 8 over x plus 8, and x squared over x squared. And then if I look at the next fraction, they have the factor x plus 8 in common. And then the last one, they have the factor x squared in common. So now I'm going to rewrite this equation with all this stuff canceled. I've got an 8 left here, a 7 and an x squared left over here, and a 1 times x plus 8 here. So I'm going to go ahead and rewrite that. That is going to be 8 equals 7x squared plus 1 times x plus 8 is just x plus 8. Okay, that is a quadratic. Whenever you see a quadratic, you need to get it equal to 0. So the first thing I'm going to do is subtract 8 from both sides. Conveniently, they both cancel, and so I am left with 7x squared plus x equals 0. Again, we just have a 2-term quadratic, so we're not really asking ourselves, what multiplies to something, adds to something. I'm just asking myself, is there a GCF? Is there a common factor? So we can see that they have an x in common. So I pull out the x, and I'm left with 7x plus 1, right? Because 7x squared divided by x is 7x. X divided by x is 1. Then I'm going to set both factors equal to 0. 7x, that'll be then 7x equals negative 1, which is going to be x equals negative 1/7. Now that I have my answers or answer, whether you have 1, 2, 4, 5, 1,000 answers, you have to check them all. So we're going to go ahead and do that. When it comes time to check our answers, again, I was just saying there's a couple ways you can show your work, because really what you're doing is you're plugging them into the original equation. So one way you can show your work is just by physically plugging 0 in. So we'll have 8 over, or the point n, into the original equation. 8 over 0 cubed plus 8 times 0 squared equals 7 over 0 plus 8 plus 1 over 0 squared. And then you can call it quits there. You can say, that's undefined. Can't divide by 0. Or you can more simply just write 8 over 0 equals 7/8 plus 1, 0. That is not true. You could say, undefined equals undefined, so it doesn't work. Right? All three of those ways show me that you know what checking is, and that if you cross out 0, I can see why. Okay, so you don't necessarily have to show all three of these steps or really spell it out. I just need to be able to see your thought process. Okay, so with like x equals -1/7, you could either say, okay, I'm going to do this. You could just write down what you're going to type in your calculator. And then I'll know, oh, okay, they know what, checking is, they know that they're checking to see if they are equal. Or you could just, and then you type it into your calculator and say yes or no. Or you could just type it straight into your calculator. And honestly, for stuff like this, someone in first period asked if I was sponsored by Desmos. For stuff like this, I love using the Desmos Scientific Calculator. You can't see right now, but maybe I'll stitch it in. That you can really just write it out like you see it, okay? Actually, I'll go do that. I'm going to show it to you on this calculator. The reason I really like this calculator is because you can type it in just how you see it on paper. It's not like one long line like on the red calculator where you really have to worry about like your parentheses and all that. So I can just say 8 divided by, it'll make it a fraction, parentheses, -1 divided by 7. Again, it'll make it a fraction. And then I just click this over button and it'll bring it over. Close my parentheses. That's going to be cubed. Okay, and then I will go down, but I'm still in the denominator, plus 8 times -1 divided by 7. And that whole thing is going to be squared. Right, so I can say, okay, I have 49.89 on one side of the equation. And then on the other side of the equation, 7 divided by -1 divided by 7. I don't actually think you need parentheses there, but I just, habit. Plus 8, and then I'm going to hit over, so I'm out of the fraction, plus 1 divided by. Now here I do need parentheses because I'm squaring a negative number. Lots of us miss this on the summation notation question. And you can see that it is also 49.89. So that means that -1/7, when I plug it in, I get a true statement. Both work, and that is one of my answers. So again, the first way you could show work, now that we're back to here, is just by showing this and being like, okay, yes, I did it in my calculator. All good, it works. Or you could just not write it out and actually do it in your calculator and then just put on your paper 49.89 ... equals 49.89 ... and then I know that you've put it in, I know that you've plugged it in because you have the right value there. So our only answer here is going to be x equals -1/7, and we are done with this problem. So now I want to talk about your homework for this weekend. It is half of the problems from a 16-question worksheet. I assigned all 16 last semester. I would love to do it, but I just don't think you guys would do all of them. So I really took some time to pick out what I think was like, the 8 most important ones for you to really be able to understand this. So you'll do those problems. I will have an answer key for all 16 though, if you want, to do some extra practice. Then, as always, you'll upload a photo of all the assigned problems to the assignment Dropbox. This is due at 7:59 a.m. on Tuesday morning. So the next time I see you. So that means that, this is it. This is like the big chunk of the lesson. So it's really important that you guys watch this whole thing through. And then I also wanted to mention that there are 3 videos with examples posted in the Unit 4 resources folder. Okay, one of them I just linked directly in the slides. This is one of the examples worked out on YouTube. It's very similar to your exit ticket. So if you don't know how to start your exit ticket, this might be the problem that you do. You might go do this, watch this video before you do your exit ticket, or maybe you watch it this weekend to help. And then there's 2 other videos that are pretty similar to the homework linked in the resources folder as well. Guys, so this is your exit ticket, and this is due before the end of class. So this is not your homework assignment. This is your classwork exit ticket. You watched this ed puzzle through. Now it's time to do the exit ticket, and then you're done with class for the day, and the rest of the time is yours for homework work time. So you'll do this problem right here on a separate sheet of paper, and then you'll upload it to the Unit 4 Learning Target 2 Exit Ticket Dropbox on Schoology. This Dropbox is in the Learning Target 2 folder of the Unit 4 folder. So the end of class for second period, that's 10:30 a.m. it needs to be in by, and then for fourth period, that's 2:30 p.m. Okay, whatever time you have left in class is for doing your homework, if you would like. Obviously, I won't know, but it's encouraged. And then again, I need everybody to submit your exit ticket, whether you completely finish it, whether you're stuck, whether you have questions, because that's going to let me know, when I come back on Monday and Tuesday, where did we stand at the end of class? Okay. I hope you guys have a wonderful weekend. I'm sad I didn't get to see you today, though I did get to meet some people yesterday at air testing. Yeah. Enjoy the rest of your day, and I will see you next week. Bye, guys.